A match flickered in the basement. Professor Louis Fieser ignited a small sample of jellied gasoline. The flame didn't explode like ordinary fuel. It clung, burned, refused to die. The Harvard chemistry professor set down his pen and reached for the secure telephone. What he had just created would change warfare in the Pacific. A weapon that could penetrate the deepest caves, breach the strongest bunkers, destroy what bombs could not touch. Professor Fieser had no idea his discovery would kill more Japanese than both atomic bombs combined. The Pacific War had taught American forces a brutal lesson. Japanese defenders did not surrender. They dug in, fortified, fought from positions conventional weapons couldn't destroy. The volcanic islands offered perfect defensive terrain. Caves honeycombed through rock, concrete bunkers reinforced with coral, underground passages stretching miles. Iwo Jima alone contained 11 miles of subterranean fortifications. Okinawa's defenders turned ancient burial tombs into machine gun nests. Conventional bombs bounced off. Artillery shells barely scratched surface. Something new was needed. Something that could reach into depths where Japanese soldiers waited. The answer came from an unlikely source. A Harvard chemistry professor working on synthetic rubber when war broke out. Louis Frederick Fieser, born Columbus, Ohio, April 7, 1899, had spent years synthesizing vitamin K and studying blood coagulation. He was about to become father of modern incendiary warfare. Aluminum naphthenate and aluminum palmitate, Fieser noted in his laboratory journal, creates gel consistency similar to applesauce, then thickens to rubber. The first field test occurred July 4, 1942, not in remote military facility, but on Harvard's soccer field. Fieser placed 45 pounds of his new compound into a shallow pool of water. Cambridge Fire Department stood by nervously. Tennis players on nearby courts had no idea what was about to happen. White phosphorus igniter triggered the napalm. Flaming globs of gel erupted into air, splashing into water where they continued burning. Tennis players yelped and scattered. The gel stuck to everything it touched. Water couldn't extinguish it. Burned at temperatures ranging from 800 to 1200 degrees Celsius. Fieser's calculations were precise. His new weapon burned 6 times hotter than thermite. Unlike gasoline, which exploded in massive fireball, napalm projected in tight stream that could be directed into cave openings, bunker slits, pillboxes. The aluminum soap compounds gave consistency that made it stick to surfaces, to uniforms, to skin. Standard incendiary bombs achieved kills in 1 attack out of 60 attempts in early trials. Napalm achieved success in 1 attack out of 3. Production began immediately. By mid-April 1942, they had developed brown, dry powder that looked harmless enough. Mixed with gasoline, it transformed into something terrifying. Chemical Warfare Service ordered thousands of tons. By 1943, America was producing 500,000 pounds of napalm. By 1944, that number had risen to 8 million pounds. The M69 incendiary bomb was designed specifically for napalm deployment. Each bomb weighed 6.2 pounds and contained jellied gasoline that would spray across 15-foot diameter. 38 M69s were packed into E-46 cluster bomb. July 22, 1944, Tinian Island, Marianas Chain. The Pacific debut. Captain Robert Johnson of 2nd Marine Division watched Army Air Force fighter bombers approach from east. These weren't carrying conventional bombs. Aircraft were loaded with first napalm weapons to be used in Pacific theater. Japanese garrison on Tinian, commanded by Colonel Keiichi Ogata, had spent months preparing defensive works. 50,000 infantry regiment and attached units, nearly 9,000 men, had excavated caves into the island's coral cliffs. Machine gun nests covered every approach. When first napalm bombs fell, Marines watching from Saipan, just 6 miles away, witnessed something unprecedented. Instead of sharp explosions of high-explosive bombs, orange flames rolled across Japanese fortifications like tidal wave of fire. Incendiary mixture penetrated cave openings, flowed into bunkers, seeped through firing slits. Japanese soldiers who had survived weeks of naval bombardment fled their positions, uniforms ablaze. Burning petroleum adhered to everything. Stop, drop, and roll only spread it further. Water from canteens caused it to splatter. Marine Corporal James Chen, observing through binoculars, noted in diary, quote, "The Japs came out of holes we didn't even know existed. They rolled in dirt trying to put it out, but it just kept burning." Within days, Marine units were requesting napalm strikes before every advance. Japanese emplacements that had required hours of costly assault to neutralize were cleared in minutes. Tinian fell August 1st. Of 9,000 Japanese defenders, only 313 survived. February 23, 1945. Iwo Jima, the volcanic inferno. Corporal Herschel Woody Williams crept toward Japanese pillbox, dragging his M2 flamethrower through volcanic ash. His unit had been stopped by interlocking fields of fire from concrete emplacements. Artillery hadn't worked. Naval gunfire had failed. Conventional assault meant suicide. Williams could see barrel of Japanese Type 92 machine gun protruding from firing slit. Bullets sparked off steel tanks on his back. 20 yards. 15 yards. At 10 yards, he triggered igniter. Stream of thickened fuel shot through slit. Bunker became furnace. Temperatures inside exceeded those of crematorium in seconds. Concrete itself began to crack from thermal shock. Steel reinforcement bars warped and bent. Machine gun's barrel turned cherry red, then white, then melted. Williams crawled to next position, underground complex connected by passages. He noticed ventilation shaft, barely 6 inches wide. Flamethrower nozzle fit perfectly. One trigger pull sent flaming gel flowing through entire system. Japanese soldiers emerged from hidden exits 50 yards away, their bodies wreathed in flames that couldn't be extinguished. In 4 hours, Williams neutralized 7 major fortifications. Positions that had stopped entire Marine regiment were cleared by one man with flamethrower. He would receive Medal of Honor for his actions. Lieutenant General Tadamichi Kuribayashi, Japanese commander on Iwo Jima, had spent years turning island into fortress. His 21,000 troops had excavated miles of passages through solid volcanic rock. They had stockpiled food, water, ammunition for months-long siege. Kuribayashi had studied American tactics, knew their reliance on superior firepower. He positioned defenses on reverse slopes where naval guns couldn't reach. He forbade suicidal banzai charges, ordering men to fight from fortified positions until death. He believed he had created impregnable defense. He had not accounted for napalm. Modified Sherman tanks arrived on second day of battle. Captain Frank Caldwell of 26th Marines watched 1st Zippo tank advance on underground fortress that had resisted 2 days of assault. Tank's flamethrower erupted, sending stream of burning petroleum 100 yards into cave mouth. Incendiary mixture flowed like water, finding every passage, every chamber, every hiding place. Quote, "The whole mountain seemed to exhale smoke," Caldwell reported. Then we heard screaming. Japanese soldiers emerged from caves, their clothing and skin aflame. Those who made it out were cut down by Marine riflemen. Those who stayed inside were incinerated. Subterranean complex, which military planners estimated would take weeks to clear, was neutralized in 20 minutes. 8 flame tanks on Iwo Jima consumed 10,000 gallons of thickened fuel per day. Psychological impact was immediate. Japanese soldiers who had fought fearlessly against conventional weapons fled at sight of flame tanks. Radio intercepts revealed growing panic. Words like demon fire and dragon tanks appeared in decoded messages. Private Toshio Yamada, one of few Japanese survivors, later testified, quote, "We were trained to die for Emperor. We were prepared for bullets, shells, even bayonets. But the fire was something else. It came into our caves like living thing. You couldn't fight it. You couldn't hide from it. It found everyone." By March 1945, napalm had proven so effective that General Curtis LeMay made decision that would change course of war. If incendiary gel could clear caves and bunkers, what could it do to cities? March 9, 1945. Major General Curtis LeMay watched first of 334 B-29 super fortresses roll down runway. Each bomber carried lethal cargo, 40 cluster bombs containing 1,520 M69 incendiary devices. Their target? Tokyo. LeMay had struggled for months with high-altitude precision bombing. Jet streams over Japan pushed bombers off course. Cloud cover obscured targets. Anti-aircraft fire at 30,000 feet was deadly accurate. Results were dismal. After taking command of 21st Bomber Command in January 1945, LeMay knew he had to try something different or face relief. Arithmetic of destruction was compelling. One incendiary cluster could destroy area 100 feet by 300 feet. Tokyo's residential districts were densely packed with wooden houses, paper walls, straw mats. Japanese war production depended on thousands of small factories scattered throughout residential areas. LeMay stripped B-29s of defensive guns to carry more ordnance. He ordered them to fly at night at low altitude between 5,000 and 9,000 feet. Lower altitude would improve accuracy and put them below effective range of Japanese anti-aircraft guns. Pathfinder aircraft arrived over Tokyo just after midnight, March 10th. They marked target Area 3 by 4-mile residential district housing 750,000 people with incendiary bombs in X pattern. Main force followed, dropping 1,665 tons of incendiaries in streams that created grid of fire. Within 30 minutes, individual fires had merged into firestorm. ground-level heat approached that of molten lava. Superheated air created winds exceeding 100 miles per hour, sucking oxygen from bomb shelters, feeding flames with fresh air. Concrete boiled, steel melted. Sumida River turned to steam. Fire Captain Susumu Takahashi of Tokyo Fire Department logged his final report at 12:48 a.m. Quote, "Fire beyond control, equipment useless, city is dying." Tokyo's fire department had 8,000 men, 1,000 pieces of equipment, and exactly 3 ladder trucks capable of reaching beyond 30 feet. They had trained for conventional bombing, prepared for normal fires. Nothing had prepared them for this inferno. Gel stuck to their equipment, melted their hoses, turned their water into scalding steam. By dawn, 16 square miles of Tokyo had been incinerated. Conservative estimates placed death toll at 87,500, though Japanese sources suggest over 100,000 perished that night. More people died in Tokyo firestorm than would die in either atomic bombing. 1 million were left homeless. B-29 tail gunner Sergeant James Corliss reported, quote, "At 5,000 feet, you could smell burning flesh. Thermal updrafts from fire were so strong they threw our 65-ton bomber around like leaf." But LeMay was just getting started. Systematic incineration of Japan had begun. March 11th brought destruction of Nagoya as 313 B-29s eliminated Mitsubishi aircraft engine plant and surrounding districts. 2 days later, Osaka's industrial heart was consumed by flames that burned for 72 hours. March 16th saw Kobe's port facilities and shipyards reduced to twisted metal and ash. In 10 days, incendiary raids had destroyed more Japanese industrial capacity than 2 years of conventional bombing. April 1st, 1945, Okinawa. The final crucible. If Iwo Jima had been hell, Okinawa was something worse. Island's 450,000 civilians were caught between 100,000 Japanese defenders and 180,000 American attackers. Japanese had turned every tomb, every cave, every hill into defensive bastion. Lieutenant General Mitsuda Ushijima had learned from Iwo Jima. His troops dug deeper, fortified, stronger, prepared for flame attack. They installed water reservoirs in caves, created fire breaks in passages, developed crude protective gear from wet cloth and mud. It proved futile. 713th Tank Battalion had been entirely converted to flame tanks for Okinawa. 54 Sherman tanks equipped with Ronson flamethrowers, capable of projecting incendiary streams 60 to 80 yards. Navy's chemical units had prepared 250,000 gallons of thickened fuel. Every Marine rifle company had attached flamethrower teams. Battle for Wana Ridge demonstrated napalm's evolution as tactical weapon. Japanese defenders had created interlocking fortifications on reverse slopes, immune to artillery and air attack. Marines of 1st Division spent 3 days trying to advance 100 yards, suffering massive casualties. On May 14th, Marines implemented innovative tactic. They hauled barrels of incendiary mixture to ridgetop, punctured them with rifle fire, and rolled them down into Japanese positions. White phosphorus grenades ignited flowing gel. Entire draw became cauldron of flame. Defensive works that had resisted for days were cleared in hours. Private First Class Eugene Sledge, observing attack, wrote, quote, The Japanese came running out of caves we didn't know existed, their clothes and bodies on fire. Some tried to surrender, but it was too late. Napalm had already done its work. They collapsed after few steps, fire still burning even after they were dead. Psychological impact on Japanese civilians was devastating. Thousands had taken shelter in caves following military instructions. When flame tanks approached, they faced impossible choice: burn in caves or emerge into machine gun fire. On May 30th, Marines discovered cave containing 450 civilians near Shuri Castle. Lieutenant John Stevens of 6th Marine Division attempted to convince them to surrender. When they refused, military necessity took over. Flame tank crew gave 3 warnings in Japanese. No response. Flamethrower ignited, sending deadly stream deep into cave system. Stevens later testified, quote, "We could hear them screaming for 5 minutes, then silence. When we finally entered, we found mostly women and children. Flames had consumed all oxygen. Most had suffocated before fire reached them. It was mercy, I suppose." Flame tanks on Okinawa consumed 200,000 gallons of thickened petroleum. Underground fortresses that would have required weeks to clear with conventional weapons were neutralized in hours. But cost in civilian lives was staggering. Estimates suggest flame weapons were responsible for at least 20,000 civilian deaths on Okinawa, though exact figures remain disputed. Weapon that had been developed to save American lives was indiscriminate in its destruction. July-August 1945. General LeMay's B-29s were now conducting incendiary raids with mechanical precision. Target list expanded from major cities to smaller industrial towns. Intelligence identified 180 Japanese urban areas suitable for firebombing. By late July, 67 cities had been attacked with varying degrees of destruction. Fukui lost 60% of urban area July 19th. Matsuyama saw 3/4 consumed July 26th. Tsu suffered 85% destruction July 28th. Japanese industrial production plummeted. Workers refused to enter factories knowing they were targets. Transportation systems collapsed as rail yards burned. Food distribution failed as warehouses were incinerated. Home front that had sustained Japan's war effort for 4 years was dying under cascading waves of petroleum flame. Prince Fumimaro Konoe, former prime minister, wrote in diary, quote, "The Americans have found our weakness. We built nation of wood and paper. Now they are burning it down city by city. There is no defense against this demon fire." Japanese military attempted countermeasures. They created fire breaks by demolishing entire city blocks. They built underground shelters with multiple exits. They distributed primitive protective equipment made from treated cloth. None of it worked. Burning petroleum found its way into every shelter, every hiding place, every refuge. Dr. Yoshio Nishina, Japan's leading physicist, was tasked with developing defenses. His report to Imperial General Headquarters was bleak. Quote, "Gel's adhesive properties make it impossible to remove once ignited. Its combustion temperature exceeds our material's tolerance. Only defense is to prevent enemy from delivering it. Since we have lost air superiority, there is no defense." August 6, 1945. Hiroshima. Atomic bomb killed 70,000 instantly. World gasped at destruction of city by single bomb.
But Curtis LeMay was unimpressed. His firebombing raids had already attacked 67 cities, with many suffering extensive destruction. Tokyo alone had suffered more deaths than Hiroshima.
Atomic bomb was spectacular, but incendiary raids had done more cumulative damage. August 9th, Nagasaki. Another atomic bomb, another city destroyed. But that same night, 95 B-29s dropped conventional incendiaries on Yawata. Conflagration burned for 2 days. August 14th, last major raid. Even as Japanese officials discussed surrender terms, 160 B-29s attacked Kumagaya and Isesaki, flames continuing to burn as diplomats negotiated. August 15th, Emperor Hirohito announced Japan's surrender. In his speech, he mentioned new and most cruel bomb, referring to atomic weapons. He did not mention weapon that had destroyed more of his nation than any other. Statistics were overwhelming. Between March and August 1945, incendiary raids had destroyed 180 square miles across 67 Japanese cities, killed between 300,000 and 500,000 civilians, left 8 million homeless, eliminated 40% of industrial capacity. 1946 National Defense Research Council report documented that 40,000 tons of M69 incendiary bombs had been dropped on Japan throughout war. Pacific War ended not with atomic flash, but with dying embers of countless fires. Professor Louis Fieser returned to Harvard to his chemistry laboratory where it all began. He had been awarded Medal for Merit, nation's highest civilian honor. His invention had shortened war, saved countless American lives, revolutionized warfare. But victory was bitter. In 1967, during Vietnam War, Fieser watched television footage of napalm strikes, children running down roads, their bodies aflame, villages incinerated. Weapon he created to destroy enemy fortifications was being used against populated areas. In June 1972, Fieser wrote to President Nixon, urging international ban. Quote, "When we developed napalm, we never thought of anti-personnel use. We were thinking of structures, fortifications. I have no right to judge morality of napalm just because I invented it, but I believe its use should be restricted." Edward David Jr. Nixon's science advisor replied that napalm use was difficult to predict or control, offering only that suggestion would receive careful attention. Fieser called it brush-off. He died in 1977. His obituary in Harvard's Gazette mentioned his work on vitamin K and anti-malarial drugs. No mention of napalm. University had quietly erased weapon from his official legacy. Tactical revolution was complete. Age of static fortification had ended. No bunker was safe from flowing flames. No cave deep enough to escape incendiary torrent. Volcanic fortresses of Pacific, carved from solid rock and defended with fanatical determination, had fallen to weapon developed in Harvard basement. Marine Corporal Raymond Hart, who served on Iwo Jima, would only say, quote, "The flamethrowers got it done." Woody Williams, last surviving Medal of Honor recipient from Iwo Jima, focused his post-war efforts on Gold Star families, never discussing weapon that made him famous. Eugene Sledge wrote, quote, "We thought Japanese were cruel. Then we brought flamethrowers. War makes monsters of everyone. Military implications were clear. Technology had overcome determination. Chemistry had defeated courage. Industrial capacity had proved more decisive than warrior spirit. Samurai tradition that had sustained Japan for centuries perished in petroleum flames. Scientific legacy proved complex. Research into jellied petroleum led to developments in polymer chemistry, fire suppression technology, materials science. Same aluminum soap compounds that made gasoline adhesive found applications in industry and medicine. But moral questions remained unanswered. Was firebombing of Tokyo war crime? Were civilian deaths on Okinawa justified by military necessity? Did incendiary warfare shorten conflict enough to justify its horrors? Historians continue to debate these questions, finding no easy answers. Japanese survivors formed Association of Tokyo Air Raid Victims, documenting testimonies, preserving memories. Museums in Tokyo, Osaka, Kobe display melted artifacts, photographs of devastation, lists of victims. School children learn about Night of Black Snow, when burning debris fell like dark precipitation. In caves of Iwo Jima, coral formations show scorch marks from flame tanks, still visible 8 decades later. On Okinawa, sealed caves contain remains of those who chose death over surrender to flames. In Tokyo, memorial parks mark areas where entire neighborhoods vanished in single nights. Professor Fieser's formula was elegantly simple. Aluminum naphthenate plus aluminum palmitate plus gasoline equals napalm. Calculus of war had become chemistry. Chemistry of destruction had become industrial production. Age of limited war was over. Standing in ruins of Tokyo, September 1945, General Curtis LeMay surveyed devastation. Quote, "We scorched and boiled and baked to death more people in Tokyo that night than went up in vapor at Hiroshima and Nagasaki combined. But it was war. They started it. We finished it." Pacific Ocean had witnessed birth of modern total war, not through atomic weapons that grabbed headlines, but through humble gel that burned unquenchably. Napalm had changed warfare forever. Weapon born in Harvard basement had killed more Japanese than any other American weapon. It had consumed nation that believed itself divinely protected. Strategic bombing survey conducted after war reached stark conclusion. Japan would have surrendered by November 1945, even without atomic bombs, even without Soviet entry. Systematic firebombing campaign, more than any other factor, had broken Japan's ability to continue fighting. For scientists who developed these weapons, moral burden proved heavy. Louis Fieser was not alone in his regrets. For Japanese survivors, trauma lasted generations. Children who fled through burning streets grew up with recurring nightmares. Smell of gasoline could trigger panic attacks decades later. Burn scars served as permanent reminders. Yet from this destruction came unexpected result. Same Japan, reduced to ashes by American firebombing, would become one of America's strongest allies. Cities that had been incinerated rose again as centers of commerce and culture. Tokyo, which suffered most devastating single raid in history, became one of world's great metropolises. In militaries worldwide, Pacific firebombing campaign is studied as both masterpiece of strategic execution and cautionary tale about nature of total war. Annual commemorations in Japan attended by fewer survivors each year. American memory of firebombing, more ambiguous. Atomic bombings dominate narrative. Systematic incineration that killed more, reduced to footnotes. Technological progression from Fieser's laboratory to Tokyo's ruins took just 3 years. In that time, napalm evolved from curiosity to most destructive conventional weapon deployed. Today, napalm and its derivatives remain in military arsenals. Principle unchanged: jellied fuel that sticks and burns. Professor Fieser spent final years teaching and writing chemistry textbooks with his wife Mary. He rarely spoke of napalm, preferring to focus on other achievements. But weight of his creation never left him. Fundamental truth revealed by napalm's use remains. In total war, there are no limits to human ingenuity in creating destruction. Same industrial capacity that improves life can be turned to ending it massively. As last survivors pass away, their memories become history. Burn scars fade, destroyed cities rebuilt, trauma processed. But capacity for such destruction remains. War ended, flames died, but questions napalm raised burn on. Lesson was clear. In age of total war, victory belonged to those who could produce most terrible weapons and possessed will to use them.
Japan's defensive positions, carved from volcanic rock and defended with suicidal courage, had collapsed under American incendiary assault. Fortress Pacific had burned, and from its ashes arose modern world forever changed by weapon born in university laboratory, tested on soccer field, and deployed across ocean of islands until it consumed an empire.